Hey everyone. Sorry I'm not there for the second day of class, but research and main calls. So today we're going to discuss and lay out the foundation for distinguishing between when I talk about wild capture fisheries versus aquaculture. And so this lecture is really, really important to understand that these are distinct things, although they lie on a spectrum. They do have distinct criteria, distinct verbiage and language around them and how we talk about them, and that needs to be clear. They are not the same thing, and they do have different implications for management and environmental impact and food production. So really understanding that these things are distinct, although somewhat overlapping and interacting. I want you to make sure that you recognize that these are distinct entities in how we discuss them in the class, okay? Because it's going to be really, I'm going to jump back and forth between wild capture and aquaculture throughout the course. And so if you miss this one, it's going to be really, really challenging. Okay. So we have 3 learning goals for today. We have, I want you to know the primary differences of production forms. I want you to be able to understand the relative role of seafood in society and recognize why differences in production ultimately matter. And I want to highlight from the get-go that both fisheries and aquaculture have been happening for thousands of years, pretty much as long as humans have been around. Here are some images from, say, the 1800s of more colonial-based fishing, as well as medieval aquaculture here in the lower end. So around for a very long time. And aquaculture and fisheries are really interesting because aquatic food is very, very diverse. What I mean by that from the get-go, both in terms of how we produce it, but also the types of species that we harvest and eat. So right now, the estimate is around 1,700 different wild species. This is probably an underestimate. Wild species that we catch in the wild and bring in and largely eat. And for farmed aquaculture, which again, we'll dive into the precise terminology here, there's about 650 different farmed species. So less, not surprisingly, from wild, but a lot of different organisms in this space. And maybe you're thinking, who cares? I have no context of whether this is less or more than something else. So let's talk about land farming, aka agriculture. So in agriculture, there's around 9,000 livestock breeds, which is a lot of breeds, but a breed is not a species. And we only have about 38 different species of livestock that we actually produce. So massively small in comparison to the species number of aquatic foods. And you think, well, maybe plants are more. Not really. We know that there's about 300,000 known edible plants on the planet, and we only use about 150 to 200. And of those, really 3 dominate in our food space, both in terms of calories and proteins. Rice, maize, and wheat contribute upwards of 60% of what we consume or use globally. So very, very homogenous landscape when we talk about agriculture in comparison to aquatic food, which makes aquatic food so much more interesting. Even more stunning is that 75% of the world's food in general is generated from only 12 plants and 5 animal species, which is kind of incredible that we've gotten so good at farming and producing a really small handful of things that prop up 8 billion people on this planet. But that's also slightly problematic because that also means that there's not a lot of resilience potentially in this kind of global food space. So let's talk a little bit more about how it fits into kind of the overall landscape socially of how we consume seafood, because that is also diverse and varies depending on space and time. So what you're looking at here is the contribution of quote unquote fish to animal protein supply, an average from 2013 to 2015. They say fish in this. This is from the United Nations Food and Agricultural Organization. It's not just fish, it's also invertebrates, so it's more aquatic food in general, but nonetheless. And it's showing the average aquatic food protein per capita per day in grams. When I say per capita, what they do is they calculate how much total there is, divide it by the population of that given country, and that gives you the overall general consumption pattern of that country in terms of seafood. And the darker colors are indicating higher levels of consumption per day, and the lighter colors lower. And so you can see there's a lot of variety and diversity in how people consume and interact. The United States, where we are, kind of somewhere in the middle. One thing I really want to note here is this equatorial band here with these yellow dots. And what those yellow dots are showing are countries that have a oversized reliance and use of aquatic foods in their overall animal protein supply, i.e. seafood is really important to that country and that food supply. And you'll notice it's at this band. You have a few countries up here in the northern kind of Arctic regions, but for the most part, it's in this equatorial band. So how much do we eat here in the United States? Well, it's about 20 pounds per person per year. So we do that calculation for an entire annual estimate, which is quite a bit, 20 pounds, not bad. However, in comparison to say something like red meat, it's just minute in terms of the overall consumption. We eat way too much red meat. Anyway, so here are the kind of relative terms of it is very important, but the relative importance differs depending on where you are in the world. And in the United States, the kind of the role that seafood plays does differ. And even as we drill down into the United States itself, which we'll talk about. And so the contributions of those aquatic foods, as I mentioned, largely come from wild capture and farmed, aka aquaculture production. And this has changed dramatically over time. So what you're looking at here is an image from, again, FAO. I'm going to mention FAO quite a bit, Food and Agricultural Organization. They're kind of your one-stop shop for global snapshots of estimates of our food system, including aquatic foods. And this is the production in millions of tons over time from 1950 to 2020 of commercial level production. And in the blues, we have capture fisheries, marine waters in this kind of lighter blue, and inland, aka freshwater production in this dark blue, and then aquaculture, respectively, marine, and then inland freshwater production. And a couple things to take away. Seafood consumption and production, and thus production, has increased over time. We see this continual increase of that, but how and what is being produced has quite drastically changed, right? It used to be pretty much all wild capture fisheries over time, and now fisheries has largely stagnated for the last 30 to 40 years. It is not totally tanking, right? Which may be a surprise to some of you, but our commercial level production has stagnated. We can't take any more out of the ocean, more than we already are, given its limits. Well, aquaculture has filled the gap over the last several decades and is one of the fastest growing sectors in food right now. And so when describing or talking about wild capture and aquaculture, and we'll dive into more formal definitions in a moment, what I want you to recognize, and this is informed by the paper that you're going to be reading, is that really distinction between the two forms is rooted in the level of human intervention, with less intervention on the full wild fishery side and way more intervention on something like the full closed, aka domesticated aquaculture side, okay? But they are connected and they do interact. And depending on where you are in the space, you're either a little more fisheries or a little more aquaculture, because not all fisheries and all aquaculture reside in these two dichotomous ways. You can have things like interventions of supplemental feeding, which you'll read about, adding more food to the environment that helps some of the species you're trying to fish, right? Low level input, but still human intervention. You can exclude predators. You can increase or try to increase the level of things that you're trying to catch. Pacific salmon is a really great way. by doing this through hatcheries, by raising the early stages and then releasing them out into the wild. You can also have aspects of conservation aquaculture that can kind of be in between. We'll have an entire lecture dedicated to that, so I'm not going to go into too much detail here. We also have capture-based aquaculture, which is the precursor to pretty much all aquaculture, which is you capture usually earlier stages of an organism, bring it into captivity from the wild, and then grow it out for harvest. So kind of the flip design of hatcheries. And then you have full close cycle. But this gives you kind of an example of the suite or array of which these systems look. And again, we need to be clear that they do interact and have similarities, but they are distinct. And they look different too. So wild capture has a diverse array of which it looks. Some people will only think about things like trawling, but hook and line, right? Recreational fishing is fishing. Yes, trawling is fishing. That's the one that comes to mind when we think about environmental types of issues with fishing. But we also have things like crab pots, traditional and subsistence fisheries, aka small scale fisheries, as well as some of the singular and most early forms of fishing, ice fishing, and spearfishing. So diverse way of which we interact with our aquatic species and acquire resources from them. And those have different cultural significance components, as well as what this means in terms of environmental impact. Right? So more formally, a fishery is an organized effort by humans to catch fish or other aquatic species through fishing in different aquatic environments. Okay? And notice in this definition, centralized in it is how humans coordinate what they're extracting from an environment. It's largely and primarily for food, but you can also do it for ornamental species. So for things like the aquarium trade, all your goldfish, for instance, although those are aquaculture now. And you can also do recreational fishing, right? Do it for fun. And within the fisheries context of that organizing, that's usually associated with the fishing efforts centered on either a particular ecoregion or species or type of fish or animal, or usually all three. And the fisheries are then differentiated by these criteria, in addition to several other components that we're now going to discuss. But at the highest level, you need to have a given region where it's happening and a species and how then the extraction is then implemented. That is a fishery, okay? And fisheries pretty much touch every reach of our aquatic environments. This is the ocean, but a lot of the freshwater systems as well. Here, what you're looking at is the global snapshot of hours of fishing of larger commercial vessels that we can see and track from space. The yellow colors are the higher concentrations of fishing effort of hours. So you can see kind of where the hotspots are for fishing and where the most productivity is around the globe, where some areas are quite dark, not a lot of production, or they are countries' EEZs, exclusive economic zones, where they have control over those waters. And so there's kind of four breakouts of the high level of that ecoregion that I described, some of that defined by the world's exclusive economic zones that were determined in 1982 by the law of the sea. But we have inland or freshwater fisheries, so that's all in the inland areas, hence inland. You have nearshore areas that reside really close to that land-sea or closer to that land-sea interface, where state level jurisdiction tends to reside. You then have federal level waters, so farther from shore, but still in the EEZ. And then we have high seas, also known as distant water fleets, that tend to occur out in the ocean, open ocean, that is beyond the jurisdiction of any country, right? So where it's a bit of the Wild West, if you will. And in addition to that kind of ecoregion or designation of where it's happening, the type of scale of how it's happening also matters too. So large scale versus small scale. So the scale of the fisheries and the associated how we describe it is kind of, there's various ways and depends on what country you're in, but in general, we can have a small scale fishery and or what is also termed an industrial scale fishery on one end, and then fishing characteristics on another axis to then give us this kind of diagonal of description here, where subsistence artisanal recreation is smaller, and then it kind of goes up from there. Determining this y-axis can be a variety of things. It can be one of them or all of them, depending, again, where you are. You can have inputs of social organization influencing that definition. So how the socioeconomic criteria are defined. So subsistence is a really great example of how and what it's being used for. If you're using it to sell it, it's not subsistence anymore. You can also, again, more formally use those ecoregions, space and time to designate what type of fishery it is, the fishing ground itself, seasonality as well. And just to give you a sense of the most extreme cases where it's very obvious what's a small versus large scale system, or excuse me, fishery, you have gleaning on one side, which is things like women going out into an intertidal zone, collecting things like clams, versus a super trawler, one of the largest fishing vessels in the world. And this changes over time of how we determine what's small, what's large. So here what you're looking at is the percent of publications from the 1960s out to the 2010s associated with what criteria are used to define small versus large scale fisheries. And what you'll notice is that there's kind of a somewhat equal considerations of things like socio-cultural aspects, motorization, boat size, and the fishing gear type. And what you'll notice is that this is largely shifted away from these components down here, especially the social cultural one, which is hard to define in a lot of instances, towards more things that are measurable, like boat size and fishing gear. And boat size, what I mean by that is usually the length of the boat and not necessarily the width, although that can and has now been incorporated into management because how we fish and people are clever over time and how it differs between regions. So for instance, defining these features and coming up with small versus large scale ends up being really important and context dependent. So here we have location A. If I were to ask you what's the small scale system, you would probably point to the one at the bottom in comparison. But going to location B, right, then the bottom one now, which was the large scale, is now the small scale. And so there's no unifying form in any given location. And so being very clear for management purposes ends up being really important because you can get special treatment if you're a smaller scale fishery, for instance. So in a lot of cases, say tribal subsistence, more traditional types of fishing efforts will get allowance to go earlier, to go fishing in a season. So that way they have first access to that resource in the fishing season. As an example, it's not the only way of which you can have differences, but ultimately it allows the smaller systems, the smaller scale fisheries to not totally lose out on that potential resource where they get outcompeted by the larger individuals. And this is mandated into management regimes and laws into given areas. However, there can be issues, especially moving away from the socioeconomic definitions and only relying on, say, the actual measurements of, say, a boat. Because, like I said, humans are smart and clever. So what you're looking at here are two distinct boats. in different fisheries. As you would guess, this one would probably be small scale, and you might say that this one's a large scale one. Well, at the time, this was in the Northeast in the United States. This particular boat, because it wasn't based on anything other than boat size, cut off the front of his hull that you can see here to then be the same length or within the criteria of a small boat to then be able to go fish earlier. Obviously, the realization by management that that's not what they meant, because looking at the width of the boat, it obviously can take more and has an advantage over the actual smaller vessels. And so these definitions and these criteria end up being really important for how we manage these systems. And again, humans are very smart. Other ways of which they're managed and identified, the different forms of fisheries, active versus passive gear types. So on the left-hand side, you see the more active gears. They're active because you need a boat to pull them along to get the fish out, versus the passive gears are things that you usually cast out and leave, and then you can come back and collect later. So things like crab pots. There's also distinctions between single species versus multi-species fisheries. Most fisheries are single, i.e. they target an individual type of organism or fish, versus other fisheries that can collect multiple different species at once. Trawls, for instance, ground fish fisheries that kind of scrape near the bottom tend to be more multi-species oriented because the selectivity of the nets and gears isn't as precise as single species approaches. Okay, so that gives you a rapid overview of wild capture fisheries. We're now going to move on to the pink world of aquaculture. So aquaculture is an interesting one because it's grown very, very quickly in a very short amount of time. What you're looking at here is a kind of different way of exploring how aquaculture has changed over space and time. So although we've seen it increase, where has it increased? This is in 1950 showing a cartogram. So the scale of production is then scaled to the size of the country, right? So the more you produce, the bigger your country in these, indicated by this kind of yellowy color, and then kind of reduced over time. So that's 1950, relatively even in the Northern Hemisphere for the most part. Drastically changes 30 years later, with China very much dominating, becoming the dominant location of aquaculture, and a bunch of other countries kind of coming online. And that kind of theme has just been exaggerated even more so over time, with China very much going all in on aquaculture production, and most countries kind of being left behind. But the productions aren't low, right? In other countries, they're just not as high as in China. And the forms vary dramatically too, just like wild capture fisheries, where you can have these lined mussel farms or gooey duck farms in the intertidal. You can have raceways for freshwater systems, or these open net pens for things like salmon. You can have more traditional forms of aquaculture, similar terminology to wild capture fisheries, growing seaweeds. You can have integrated aquaculture systems with agriculture. This is in fish and rice paddies. And you can have intensive systems right on the coast here. These are shrimp farms. And aquaculture, the kind of formal definition to it, and how it dramatically differs from that of the broad definition of wild capture, is that you're breeding or rearing fish, shellfish, algae, or other aquatic organisms in captivity at some point, usually in their life stage, and that when they are harvested, it ends when they are in captivity, versus say hatcheries, right? And similar to wild capture, it's typically for harvest of food consumption, but not always. As I mentioned, there's 650 different farm species that can be kind of categorized in these 4 taxonomic groups. And the reason this is important, because obviously these taxon also exist in wild capture. But the reason kind of calling this out for aquaculture is that we have specific terminology in aquaculture where we can divide out the type of production based on whether they're fed species or unfed species. Fed, of course, all of them need to eat, but fed species means that we're actively putting stuff into the environment, versus unfed species usually refer to filter feeders like algae and mollusks that can extract things from their environment and don't necessarily need humans to feed them. Of course, there's always exceptions to the rule. Abalone, which are mollusks, are fed. Big head carp, for instance, huge production of the species, is herbivorous and doesn't require input either. But for the most part, it generally follows this line. Fed conditions, we're going to go in more detail to that, but it ends up being a really defining feature of aquaculture and can look different depending on the system. So you can have fed systems like this that you use compound, also known as pellet feed, really similar to like if you have a fish tank at home and you sprinkle little flakes in it, that's kind of the equivalent here. You can also just feed fish directly fish. This is an example of a tuna farm. How you feed them also differs and will have different impacts on the system. So you could just dump a whole bunch of feed into your system, or you can be very regimented and precise with automation into your system as well. The feed dimensions are so interesting. One of my favorite things to talk about with aquaculture. Okay, so very similar to wild capture fisheries, there's different ways and categories that they are defined. Of course, the different environments, similar to wild capture, how we talk about them geographically, scale, cultured species types, very similar to wild capture. So we're going to focus on the center portions that are pretty defining and different than wild. Starting with culture intensity. So this is how we talk about how much is farmed, ends up being rooted and comes from agriculture. So let's talk about farming intensity. So farming intensity kind of goes from left to right of less intense to more. Starts with traditional aquaculture. Then we move up to extensive, semi-intensive, intensive, and super intensive. That should be over there. And it goes from less to more. And by less, I mean things like the density of the number of organisms that are there in a given area, the seed source, so where we're getting the organisms from, the feed, the water, the aeration, the labor, the yield, all differ depending on where you are on this line. Oh, there we go. And so we're going to talk about it in real terms, and we're going to use shrimp as an example because shrimp is a really kind of clear distinction of these two of these very distinct forms, extensive versus intensive. Okay, so let's start with extensive. What does that mean? So when we say extensive, it means that you have less density in the given area. You also tend to have much larger areas that you have to be able to grow it, right? More area, fewer individuals. Usually you rely on wild inputs of larvae, so capture-based aquaculture, mostly dependent on natural feed, and you don't have those compound pellets that I mentioned. Mostly tidal-driven, no aeration, very small labor force because there's not a lot of technology to upkeep in the process, and the cost is kept down because of that, but it also means that you don't produce very much, i.e. yield. Yield is really important in production because it's the amount that you can produce in a given area. And because you can't produce a lot in an extensive systems, you need more area, right? Okay. One great example of that, traditional and extensive, are the farms in Hawaii. Hawaii has an ancient fish pond on the island. And last estimates were in the 1930s, they had over 450 of these traditional fish aquaculture ponds growing things like silver mullet, which are native there. The estimate is that these farms were feeding at least 1 million people before European colonialization happened. And after that, they pretty much all disappeared, though they are bringing many of them back. There's several that are now in operation, though not at large scale productions yet. And now today, Hawaii, instead of being self-sufficient from these farms, now rely on mostly imports from other regions. Okay, so that's extensive. Let's talk about intensive. Very small area for intensive production systems because your densities are higher. So 0.1 to maybe 2 hectares compared to the 1 to 100 hectares. Very, very high densities. You largely rely on things like hatcheries, so you have to be able to spawn and create your own seed to produce these things. Usually you have to rely on inputs, lots of inputs, because you have these higher densities, and we'll talk about carrying capacity and things like that next week. But you need artificial feeds, you need pumping and cleaning of the systems, aeration, more workers to deal with the scale that we're operating on and the technology. It also means it costs more, but you can also produce a ton more food. And in fact, you can have super intensive production systems producing upwards of 100 tons per hectare. Lots and lots of production. And intensive production systems look like this. Very different. Where you have feed inputs, cages all around, aeration systems. That's what these little white dots are here, aerating the system, increasing the oxygen in it to produce higher yields systems. And although I'm not going to give you an answer, as we wrap up this lecture, I want you to think about what's better for the environment if the goal is food here. Okay, so think about that in terms of intensification. That may or may not be on a test. Okay. All right, let's move on from culture intensity, talk about culture method. So culture farming method, monoculture, pretty clear. You produce one thing and that's it, one species. That's very common in agricultural practices on land, and you can see it in aquaculture as well. This is a farm of tilapia. Polyculture. Polyculture is growing different species next to each other, or a variety of different species. In this case, this is a integrated multi-trophic aquaculture type of approach where we have salmon farms here, integrated with seaweed farms here, where the effluence of the seaweed from the salmon farm, in theory, flows here and helps nutrify and grow the seaweed and cleans up the water while that happens. And then integrated systems. So kind of similar to polyculture and technically could fall into it, but integrated systems specifically mean that it's integrated into agricultural aspects and other forms, and not to aquaculture species per se. So again, rice fields and fish. Okay, so different culturing methods. And last but not least, water systems. Oh, and I should note, since this paper was published, it used to be that we had these different forms of open, semi-enclosed, closed water systems, only being associated with brackish and freshwater, but marine now has these too. All right, so closed systems look something like this. They're also termed recirculating aquaculture systems, aka RAS, where everything is contained and the fish or organisms never see the light of day. They're not exposed or connected to a wild water source in any way, shape, or form. There is then semi-enclosed, where you're kind of closer to or near a wild water source. So in this case, this new structure that's developed for marine semi-enclosed environments, where here is the net on top. This is what you would see for like a net pen, but below, instead of being an open net with a whole bunch of mesh, this is completely closed off, permeable to water, but fish can't see the outside or interact with it. And so this would be considered semi-enclosed. And last but not least, the open net pens, which look similar on the top. I should have a side profile for you, but if you look underneath the water for open systems, it's just a whole bunch of mesh netting that you would see for like a fishing net or something like that, but kind of at the bottom, holding in the fish. Okay, so why do these differences matter for fisheries and aquaculture? Who cares? Well, depending on the type, resource access and requirements differ substantially, as hopefully that has been indicated in the different forms of what you would need, gear, resources, money to do this. It also dictates the scale of that food production. There are clear differences that are then connected to cultural or livelihood value, not just economic considerations, right? That have meaning and can inform and influence management of these systems. It also then results in different vulnerabilities and risks to these systems, depending on what they are, how they're farmed, or how they fish. Though these things are influencing each other, obviously management ends up being a really important part of why defining these different categorizations and why they differ and how they differ matter. And environmental impact. That's a really big one, and we'll talk about that more in other lectures here. One thing I want to note as we're moving forward and you're thinking about the question I asked when I prefaced that to the intensive aquaculture question, though arguably that could be asked across the variety that we just talked about. But I want to emphasize in this class, and hopefully throughout these lectures become clear, is that food is this really interesting, complicated gray area of that everybody wants to have zero impact, which is just not going to happen with food production. Food is essential, food is important, it's cultural, it's joy, right? I love eating. But it has an impact. Food has impact. And there is absolutely no free lunch ever. So anybody that says, oh, this type of farming or this type of wild capture has no, there's always an impact. The goal, though, is to reduce that impact. And relative to what, right? Counterfactuals here are really important. Okay, this is something I'm going to hopefully instill in you throughout multiple lectures, and that we have to get comfortable with there will be impact, but the goal here is to figure out solutions to reduce it. Okay, so in summary, seafood is an important part of food, culture, our economy. Fisheries versus aquaculture, typically distinguished by harvest method and the level of effort that's put into it. And all seafood production has different forms of impact, and distinguishing those forms and can help how we think about them, manage them, and propose them for sustainable seafood futures. Okay, don't forget to read your discussion paper for your discussion sections. There's no class or quiz this Friday, as I mentioned on our first day, and I will see you all next week.